Thank you very much. My name is Hanno Voet. I come from the Laboratory for Machine Tools and Production Engineering, also located at RWTH Aachen University. In my little talk here, I'd like to address the topic of energy efficiency from a production point of view. So the main motivation for companies in that context, from our point of view, is still the aspect of costs. And in my talk, I'd like to address how this will also be related to smart metering and also production steering, for which smart meters are also a great enabler. Perhaps to start with this short motivation. So I think all these topics that I collected on this slide are also quite popular in the news. So when we are talking about energy efficiency and about environmental and energy efficiency in production, it always comes down to these basic three motivations. So one aspect is just the limit or the finiteness of natural resources. So looking at our classical energy resources like brown coal, stone coal, and so on, we see that they are just limited. And in a few years, or also in a few decades, perhaps more or less, also in production, we have to look for other fields of energy, so which is a big enabler also for renewable energies, which are then integrated into the energy net. The second point is environmental pollution, which is also a key aspect. For example, now looking at Beijing or Paris, talking about smog and so on, we see that just relying on existing energy structures is not really sustainable and leads to several challenges also in our day-to-day life. And the third aspect, perhaps for companies also a very relevant one is just legal changes. So for example, the reduction of CO2 emissions, just regulated by the European Commission or by the European Union, is a legal change which is also relevant for companies. So also if it comes down to improvements in energy efficiency, companies have to think about how can we fulfill these requirements which are now defined via the law. So this is basically one of the main changes or the main challenges which I'd like also to address on the next few slides. And the key question is now, how do all these factors affect producing companies? Because talking from a classical point of view or from an egoistic point of view, companies could say, okay, environmental pollution is not our problem, or also the finiteness of natural resources, okay, let's put it, or that's the responsibility of the energy providers and so on. But the basic motivation for that is always costs. So if you want to motivate companies to make or to think about a certain topic and also to consider a certain new topic, it's always that you try to internalize external costs, so cost regarding the environment. And this is basically also the key aspect and the key motivation that we are looking at our institute. So talking about costs and talking about perhaps talking about some specific figures, it just you also see that today and in today's industry, the costs for energy are already a big factor. So, for example, on the left side of the slide, I just collected a few figures regarding the German industry in 2010. Of course, I took some figures from from companies that have a high energy consumption, but you see that only in Germany, for these four sectors, so chemical processing, paper industry, metal production, and also non-metallic, or the production of non-metallic mineral products, you see that they already sum up to an amount of 5.8 billion euros for electricity. And also looking at a few statistics more, you see that these prices for energy and especially also for electricity, so the electricity rates on the right side, increased over the last decade. And the trend is still expected expected to raise further. So this is basically a big factor that also comes into thinking of companies. So the motivation via costs, so the reduction of costs. Then looking at the today's price models for companies. So what are the basic electricity rates that companies have to cope with today? I just collected an example of a tariff or tariff rates that are used in Aachen from our local energy provider. But I think this applies to basically most companies, at least in Germany and also in Europe, that the electricity rates are basically made up out of these three elements or these three categories. So on the one hand, or as a basic cost rate, you have the user fee that a company has to pay. This is basically the fee that comes from the maximum peak load that a company has to or needs over a whole year. So it might well be the case that in a special industry you only have one big peak in your electricity consumption, and this is basically the factor out of which this user fee is made up. So one big peak destroys your cost balance here in this cost category. And we also asked the local energy provider, okay, can you make a guess in how many cases or how many % of the year in time this maximum peak load is achieved by most of the companies? And they said in a typical case, only in 2 to 5% of the time per year, a company or a typical company really needs this high amount of electricity. The other factor then is variable electricity costs. This is basically, I think, what everybody of you knows as from your personal electricity bills. So this is basically a variable cost factor depending on the amount of energy that a company actually consumes. And just one aspect here is this is now a quite steady curve here in this picture. But as we already heard in the previous talks, this electricity rate will also be variable in the future. So we're talking about perhaps even rates or different rates from hour to hour. So at the moment, it's more or less day and night rates for most companies, at least in Germany, but we are expecting, and it is definitely expected, that these rates will change in the future also from hour to hour. And the last cost factor or cost element is our legal duties, so basically taxes that the company has to pay for its energy consumption, which is basically one cost factor that is not that influenceable by the companies, but it's also one element that these costs are basically made up of. So now from a company perspective, talking about cost optimizations and talking about how can costs be minimized, we see basically two possibilities, which are also motivated or located here in the energy cost diagram. So the first one, which is also basically, I think, a possibility that is quite famous and widely used in the industry, is a minimization of costs by process optimization. So by looking at the processes in detail, looking at the process parameters, companies try to reduce energy consumptions, and also by, for example, trying to recycle or to use, for example, scrap out of the production process and feed it back again into the process. They try to minimize costs for all resources that they use in the production process. The second one is basically also the possibility that we are looking at in the project FINESC, and which is basically also the key assumption and also the key possibility in our use case there, which I will introduce in a few minutes or a bit further on. This is basically what was also addressed in the previous talks here, the possibility to reduce energy costs by reducing peak loads. So trying to reduce this your maximum of energy consumption by an intelligent production steering and by distributing the consumption of the different machines and tools and resources that you have in the factory by distributing it intelligently to a quite steady state or to a quite even level. So what is the basic enabler for this approach, and also what is the basic solution approach that we're using within Finesk? It's basically in Germany it's quite famous under the term Industrie 4.0 or Industry 4.0, just translated, which is just another word for or Internet of Things is of course at least one part of it. So the key term for us in the context of Industry 4.0 is the term smart factory. And in a smart factory, which is also just a small definition, or smart factory shows a higher level of interaction between the different employees and also between the machines themselves and all the technical resources that are integrated into a factory. And by using this approach and also by using this new possibilities that arise with this, we're able to look at a more energy efficient production steering. So the key aspect here is basically the horizontal and vertical data analysis. Coming from the company perspective, we're basically always in the as a small, or let's say a sandwich between the level above us or the layer above us and the layer on below us. So looking at the production steering below us, it's basically the machinery and technical resources level. So when we're thinking about a more intelligent production steering, it's necessary to measure the energy consumption of the different machines, and it's also necessary to enable the different machines to communicate with the production steering, so with the production planning department, and also with each other. On the other hand, for an optimization or for an energy efficient optimization, which I already motivated, is basically relevant or measured in costs. It's necessary to get the current energy data and the current energy prices. So this is basically the layer above us, so the virtual power plant, as we call it in Finesk. So more or less for us, in our use case, it is relevant to get the current prices for energy. So as I said, in the future, it's very likely that the energy rates will change from hour to hour, and this is basically what we need in our scenario here. So, and what are we then doing in detail, or what is the basic purpose of our use case within Finesk? On this slide, you see a small picture of the demonstration factory in Aachen, which is located quite near our institute there. And in the demonstration factory of Aachen, we have the great possibility to test and evaluate our concepts in a live environment, so in a running production. And this is basically also what we're using it for in this specific use case. So the demonstration factory is not just a concept or an institution that was developed just for Finesk, but it's one institute that gives us the chance to test our use cases there in a live environment. So what is it basically? It's a production of two different products is planned there at the moment. So it's basically the street scooter. I will also come back to this product later, and an e-cart. So the street scooter is basically an electric vehicle, and the Max e-cart is, as it says, a cart, but driven by an electric motor. And in this live production, we have basically 3 different fields of interest which we are looking at there. The first one is the ERP Innovation Lab. So in this factory, 4 different ERP systems are integrated there in different areas of the factory. And one aspect there is how do these ERP systems communicate with each other? How are the interfaces designed, and can they communicate with each other? Then the Smart Objects Innovation Lab. So how can intelligent objects also be integrated in the IT system? And the last one is basically the Service Science Innovation Lab. So the main focus here is on service innovation. Within Finesse, of course, the second one, the Smart Objects Innovation Lab, is more or less the field that we are addressing there. So perhaps a closer look into the factory. The demonstration factory is basically, or this is a basic layout of the demonstration factory. I think just to give you a small, or just to show you what are the dimensions of this building. It's basically, I guess, so this side here, so this vertical side here should be something like 50 meters, and the other side something like 150, just a rough guess. I don't know the exact figures. And in this layout, basically these 2 products here are produced. So the Maximum E-Card, this is, as I said, a card with an electric motor, so a toy for adults, as we say in Aachen. So it's not designed for children, but basically a product that will later be actually sold also for adults, for example, for going to the forest or going a bit off-road in the weekend with your card. And the other one is the street scooter, which is an electric vehicle elaborated or developed in collaboration with Deutsche Post, so the German mail company. And these 2 products are running on different ways through this production, and this gives us the chance to look at the production steering and also the differences between these 2 products a little bit closer. So the relevant area is also marked here. So the blue ones here are the machines that we are also looking at in Finesse, so which we are applying the intelligent production steering that we are developing at the moment to exactly. So the first one is a laser cutting system, or basically so a small machine that is basically necessary for cutting your tailor-made blanks into different smaller ones. Then the press brake system. The press brake system is a second machine, and the laser welding system as the third one. So these are basically the machines that we are trying to look at in Finesse. What is the basic idea then behind this use case? It's on the one hand the conventional production steering. So this is basically the status quo. Looking at the different machines that you have in a production, in a conventional production steering, you're just looking at capacities. So you are not considering an energy efficiency, and you are not considering what is your electricity load in your production. So this is basically then the result of a typical measurement curve, of course, idealized in this overview here. You have this maximum peaks. And in Finesse, we are trying to reduce these peaks up to a quite steady load in the project by shifting capacities and production times between the different machines intelligently. And this is also the interesting point here is the logic behind that also puts new ideas into focus. So, for example, in a classical plant or factory, you're always planning for maximum output, but looking at higher energy costs, and from that perspective, also other ideas or other production steering logics might be relevant. So, for example, is output everything, or is costs the main factor, or how can we introduce energy efficiency into the basic or into the cost model? So this is basically what we're looking at in Finesse then. So as I'm running a bit out of time, just a few marks. So what are the next steps in the research projects, and what are we working at the moment. So we are basically at the moment in the phase of the installation of the energy measuring instruments and also the meters into the company. We will also expand this use case virtually a bit, so by simulating energy consumptions of factories, of machines, sorry, that are not actually there at the moment, but we have some colleagues that are working on that. Then of course the data acquisition and evaluation will be a huge phase in the project, and as we are also at the moment in the development of the production steering logic, and then validation and technical implementation of interfaces and so on. So this is basically what we're looking at the moment, and thank you for your attention.